Hey, what's up, guys? This is Cheng here. So today, let's take a look at one of the Codeforces problem, three integers. So you're given like three integers, a, b, and c, right? So a is smaller than b, which is smaller than c. So in one move, you can either do a plus one or minus one to any of these integers. And you can perform such operations, you mean any number of times. Okay. And so, but you cannot make non-positive numbers using such operation. So which means that all of the numbers has to be greater than zero. And our goal is to find basically the minimum operations so that we can make these three numbers is divisible from left to right, which means that after several operations, so a is divisible. Sorry, so b is divisible by a, and c is divisible by b. Okay, so then we need to answer like t independent test cases, right? And we have some examples here, right? So the output, right? So the output is the minimum operations, and the next one is the three numbers, right? So for example, for the first one we have 1, 2, 3, right? So for this one, we only need to make one operations, which means that we just need to decrease 2 to 1 so that 1 is divisible by 1 and 3 is divisible by 1 as well. That's why the answer is 1. Yeah, so on and so forth. So for this problem, at the beginning we might want to find like a greedy approach, but for this problem, there's no greedy approach. Basically, there's no like optimal solutions that can lead us to the minimum number of operations. So which means that we have to basically do a brute force, right? So we just have to try all the possible combinations for A, B, and C. But we cannot blindly do it because we have a range, right? So the range, the A is in this one, so we can only try in a certain range, because we can always keep increasing a, right? We can make this a huge number, and we can also increase b to a huge number as well, right? Increase c to a huge number. That can also give us like the answer. So the tricky part for this problem is that how can we find the proper range to do our search? So the way we do our search is that basically we'll loop through all a's, and then from a we can loop through all the b's, right? Also within the range. And with this b here, it's going to be easy for us to find the c, because as long as we have fixed b here, all we need to do is that we just need to find the c that is closer to this initial value here, who is who can be divisible by this b. Okay. And the problem is that how can we fix a and b here, right? So let's try this one. Let's say we have a, b, c, right? So let's say a is equal to 3, equal to 6. So b doesn't really matter, right? So we have a b equal to some numbers, right? Maybe 10, right? And then c maybe 20. I'm just trying to give us some random numbers here. So let's say we have a equals to 6. And what's going to be our search range for a? Obviously, a needs to start from 1. Okay, but the problem is that when is the upper bound for our search for a? Okay, so what's going to be the upper bound? So the upper bound actually is a 2 times a. And why is that? Because in this case, basically the 2 times a is 12, right? So why is 2 times a? Because if our search range is greater than 12, it means that we might as well just decrease this 6 to 1, right? Because let's say if the search value is 13, it means that from 6 to 13 we need to do 7 operations. We need to plus 7. That's going to be 7 operations. But we might as well just decrease the 6 to 1, which is only like 5 operations, right? And why do we don't need to search this 13 value of a here? Because if we decrease 6 to 1, actually 1 has much higher chance for to be can has a much higher chance that the next number b, right, can be divisible by it. Actually, the similar, right? Because b can any number can be divisible by a. Is divisible by 1. That's why if the search range is greater than 12, we know that okay, if we instead of spending the same operations or even like more operations to reach like the bigger number here, we might as well just use a decrease operation to bring the 6 down to 1. That will definitely give us like a better option, a better result, like I said, because 1 has much higher chance to be can be divisible by any other numbers there. That's why the search range for a will be 1 to 2 times a. Okay. And similarly for b, actually, so let's say we have fixed a, right? So let's say the range for a is 1 to 2 times a, right? And then for b it's kind of easy, right? Because we just need to add a every time, right? So it's going to be a so let's say the range for this one is AA, right? That's going to be our current fixed value for a, right? And then for b we have the bb. Let's say it's the range for bb, right? So the range for bb is going to be, what's the range for the b? It's going to be, of course, starting from AA, right? That's going to be starting point because b has to be divisible by a, right? That's why it starts from a, but it ends similarly as 2 times b. So the reason for that is similar as the first one, like a number a here, So if the search range for b is greater than 2 times b, so we might as well just bring this b down to this 2a, to the same as this a, so that we can have like a better chance, like a higher chance that we can find like a c that's can be divisible by a, by b, by this bb. Because the smaller the value is, I mean, the higher chance we can find like the next number that can be divisible by this current b here. Yeah. So I think that's how we fix a and b, right? And once we have a b here, so the only thing left is for c, right? So like I said, if we have fixed a b here, we just need to find the closest number, right? Comparing to this c here, who can be divisible, who is divisible by this b and b, right? And for that, we can just do this, right? Do a b times c, do a floor, right, by this bb, right? So that's basically the how we can find the closest index, the closest values for that, and then we just either do a plus b, or we don't plus it, right? So it's going to be like an optional here. That's why, because let's say we have a bb equals to let's say we have 15 here, right? Let's say bb is 15, and then the c is, yeah, let's say c is 27, right? So let's see c is 27, and to be able to find the closest place for cc, which is divisible by 15, basically we need to try two values, right? So the first value is so if we do this one, if we do like a bb times this one, we have 15, right? So we have we have 15, and then we have 30, right? Basically, we need to try both those two values and then to do a like absolute difference with 27. Basically, we need to find like two values on the left on each side of this 27, so that we can be sure we find the closest one, the best option we have for this C. That's how we use this one to find the last numbers. Basically, we need to find the 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 first number on the left of C that can be divisible by B, and also the first number on the right of C that can be divisible by B. And then there you go. And then we can just use that to maintain the smallest operations for all those kind of scenarios. And then we also maintain the final answer along the way. Cool. So I think that's basically the idea here. And let's try to run, start coding here. Okay. Cool. So to start with, right, are we gonna have some integers? Basically, we just need three integers, a, b, and c, right? That's only three integer variables we need here. And now let's read this data, right? And then we have our final answer, right? So since we're getting the minimum, so we initiate with the int max, right? And then we also maintain like a equals to 0 and b equals to 0 and c equals to 0. That's gonna be the final answer. We're gonna the output. So then let's loop through a first, right? So I'm use two a's to represent the cardinal values for a. It's gonna be a. We start from 2a, right? 2a, and then we do a plus plus, right? So that's that. And how about b, right? So for b, like I said, it starts for a, right? And then the upper bound is 2b. And then this time, right, so the step is going to be bb times plus aa, right? So that's the way how we guarantee that bb is always divisible by a, right? And then the last range is the c, right? So since we need to get both the left and the right numbers, comparing with c here, so I'm just going to use a simple loop here. So k gonna be 0, and k is smaller than 2, and k plus plus. Okay, so here, excuse me. Okay, yeah, sorry, this is k here. And then for CC, right? So for CC, what's going to be the CC? It's going to be B times C do the modular with B, right? And then we times plus K times B, right? So since we have this for loop here, with 0, we have the numbers on the left of the C here, and with K equals to 1, we have the number on the right of C. Now we can finally calculate our answer. So we have ops, right? Operations going to be absolute difference with a minus a, right? Plus b minus b, and then plus c minus c, right? So, and if ops smaller than answer, right? And then so we do answer equals to ops, and then a equals to a, b equals to b, and then c equals to c, right? So, and then we just output in the end, right? Count answer, right? And then NL, and then the count of A, B and C, right? And then NL. Yeah, I think that's it. Yeah, let's try to run some like test cases. Let's see here. Where's the test case? So let's copy this one here. Copy. So we're expecting some numbers here, right? So one, that's basically the number we're trying to check here. So okay, so let's see what we have here. We have 110. Yeah, but I think we might have a bug here because here we're expecting 3 here, not 110, right? Oh, I know why. So here should be C, right? Uppercase C. Yeah, so this time looks right. So we have 113, 1 and 113 and 102, this one, so on and so forth. Okay. Yep, I think this one works. So yeah, I think basically that's the idea for this problem. You know, it's just like a brute force search, but with a little bit of the technique, like how can you find the proper range of a search, right? And then after actually the only thing you need to realize that the search range is like between this the starting point and the 2 times of the number itself. And as long as you can realize that the search range and the left, it's pretty straightforward, right? Like C, we have to compare, find both the number on the left and on the right. And cool, I think that's it for this problem, and I'll stop here. Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.